Hello everyone, I'm Nagraj, your Perf Test Coach. Welcome to this lecture. In this lecture, I will introduce you to AWS Lambda and also we'll go through few key concepts which are specific to AWS Lambda. After this lecture, I will also be adding couple of case studies based on Lambda performance testing projects which I recently worked on. Whether you are a developer or a performance test engineer, the knowledge that you gain here will help you a lot when you are working on Lambda based projects. You will know which areas to concentrate when building and tuning Lambda based applications. So let's get started. AWS Lambda is a service provided by Amazon Web Services. It is a serverless platform, so as a developer, you don't have to manage any servers. All that you need to do is write a code and upload it to AWS Lambda. Lambda will then take care of running your code on EC2 instances with high availability. AWS will manage the servers on which your code runs, so as a developer, you can just focus on building new features. Isn't that amazing? There is one more amazing thing about AWS Lambda. Your code sits idle until someone invokes it. So, you are not charged if no one invokes your code. This is a game changer for startups with lean budgets. You only get an AWS bill if people are using your serverless applications. The code that you upload to Lambda just sits idle until someone invokes it. When your Lambda function gets invoked, your code is initialized and a new running instance of Lambda is started. Initialization of code takes some time, so this is called a cold start. If one instance of Lambda cannot handle the incoming request, then more running Lambda instances will be started until there are enough Lambda instances to handle all the incoming requests. You need to note one thing here. Lambda instances will be recycled frequently if there are no active requests on Lambda function. So, for applications requiring millisecond latencies, we might need to consider provision concurrency. Provision concurrency means your Lambda function will not be recycled even if there are no active requests on your Lambda. If you cannot afford to have high cold start time, then it is a good idea to have provision concurrency. Here is the summary. AWS Lambda will let you run your code without provisioning or managing servers. Just upload your code and Lambda will take care of everything required to run and scale your code with high availability. Your code sits idle until someone invokes it, so you are not paying anything if no one invokes your code. With AWS Lambda, you are charged for every 100 milliseconds your code executes and the number of times your code is invoked. Below snapshot shows Lambda cost calculation for 1 million API requests. For this calculation, I have assumed that this API needs 512 MB of memory and average execution time will be 700 milliseconds. So, 6 USD for 1 million API requests. Not a bad deal, isn't it? Below snapshot shows Lambda cost calculation for 1 million API requests with provision concurrency. The cost comes up to 18 USD for 1 million API request. In this case, I'm assuming we are having provision concurrency of 3. Let us go through the key concepts of AWS Lambda. When we make first request to AWS Lambda function, a new Lambda instance will be initialized and this is called as cold start. The Lambda initialization time or cold start time may vary anywhere between few seconds to few minutes based on the size of your code and compilation requirements. If there are concurrent requests on Lambda functions, then more Lambda instances will be initialized until there are enough instances to process all the concurrent requests. Lambda instances will be recycled frequently if there are no active requests on Lambda functions. Your Lambda may be recycled after 5 minutes or 5 hours. Basically, AWS decides the recycling frequency, so we don't have any control on this. So for applications requiring millisecond latencies, we might need to consider provision concurrency. We can use autoscaling for provision concurrency, either based on a schedule or Lambda usage metrics. Instead of running your Lambda function 24/7, you can scale up and scale down your provision concurrency using autoscaling feature. AWS Lambda use cases. So where can we use AWS Lambda? We can use Lambda for literally any kind of workload, which can be processed within 15 minutes. If each request is expected to take more than 15 minutes to process, then you cannot use Lambda. One more thing to note, when using Lambda, we will not have any control on the servers on which our code runs. So you will not be able to do SSH to the AWS EC2 instances on which your code is running. Lambda can be used to build serverless websites. Lambda can be used to build backend or APIs. Lambda can be used for real-time data processing. You can either add Lambda as a consumer for AWS Kinesis, SQS, SNS, etc. You can also use Lambda to process batch jobs like file processing, etc. Do we need to do performance testing for Lambda? The answer is obviously yes. There are few things to take care when we are developing solutions based on AWS Lambda. Every AWS account has maximum concurrent Lambda functions that can run. So before deploying your application into production, you need to do performance testing to find out how many concurrent Lambda functions your application needs. And also, every region has initial burst limits, which means if there is a sudden spike in the load on your Lambda function, then requests will be throttled. For few regions, the burst limit is 500, and for few regions, it is 3000. Every implementation is different. So we need to do proper performance testing to understand Lambda concurrency needs. You need to have proper throttles in place, otherwise too many Lambda functions can start and flood downstream systems. In case you are using Lambda to process real-time data from AWS Kinesis streams, then you need to do performance testing to find out how many shards you need in order to process the expected peak load. As of August 2020, only 10 concurrent Lambda functions can read data from each shard. So if we know how many data these 10 Lambda functions can process, we can plan to provision shards based on our requirements. I'm planning a couple of Lambda case studies in this course which are based on Lambda performance testing projects that I recently worked on. So all these concepts will be very clear when we go through those case studies. So stay tuned. I'm Nagraj, your Perf Test coach.